Okay, so now what happens if the density isn't constant, right? It's lighter at the top of the crust, it gets denser and denser as you go down. Well, let's think about this. Suppose you have a density of, you have 2,700 kilograms per meter cubed at the top of the crust, and let's imagine you have at the bottom, it's equal to 3,100 kilograms per meter cubed. What is rho average? Okay, well, if you're averaging over the entire thickness of the crust, the average density, if it's a linear function, is just going to be, what, 2,900 kilograms per meter cubed. But what if you have some other function? How would you calculate it? Average of rho is going to be the integral from 0 to whatever depth you want, z, of whatever your function is. Okay, so let's say our function is 2,700 plus, and so if this is, I don't know, 40 kilometers for the bottom of the crust, so what is that? That's 10 kilograms per meter cubed per kilometer, right? So 10 times 40 is 400, add it together. So this is going to be 10 times z, this is in kilometers, right? So we're going to take this dz, we're going to integrate this from 0 to our depth z, and then we're going to divide by z minus 0. Okay, that's the definition of an average. It's the integral of the function divided by the limits on the function. Okay, so if we take this, we get rho bar 2,700 z plus 10 z squared over 2 evaluated at 0 and 40 divided by 40 minus 0, right? So then if we expand this a bit, we get 2,700 times 40 plus 5. And here I'm going to do 40 times 40 for reasons that'll be apparent in a minute. 40, okay. We don't have to worry about the zeros, that's just 0, all divided by 40, right? And so a bunch of these 40s cancel out, and we get rho bar equals 2,700 plus 5 times 40, 200, is equal to 2,900. What is this? Kilograms per meter cubed, right? So we get the same number, right? It's pretty obvious the average density, if you're going from 2,700 to 3,100, has to be 2,900. But this is formally how you would calculate it to come up with an average density of 2,900. What's the advantage of this? Well, you can put any function you want in here, right? You could have the density increase faster with depth, sort of flatten out if you want, or you can have some other kind of function. Doesn't matter, this will always work.